Hi, welcome to Module 7, Creep. Creep is really a description of the type of failure mechanisms and deformation that occurs under constant loading at elevated temperatures. Now, as we'll discuss in this module, an elevated temperature is really a relative measure. Most metals and ceramics creep at high temperatures, which we do encounter all the time in engineering design, but some materials, like polymers, can actually creep at room temperature because their glass transition or other transition temperatures are well below room temperature. So creep from a temperature point of view is really a relative phenomenon. We often think of it as a high temperature phenomenon, but as we'll see, it can occur under more moderate temperatures as well. The goal for this module is to understand the mechanisms that are happening within the material at the microstructural level that allow creep to occur, to explain creep testing methods, because just like fatigue, we can't run 10-year tests in the laboratory, so we develop test methods to accelerate the creep process and then extrapolate those results to long-term service conditions. We'll look at the very specific mechanisms and how they differ in materials and different microstructures, and we'll use creep mechanism maps to get an appreciation that for a given loading situation and a given temperature and a given material, which creep mechanisms we expect to occur and what creep rates we expect to occur. There's a steady state portion of the creep process in the stage 2 of creep where you tend to get steady state creep rates. If we can predict these, we can use them in design to predict the amount of creep deformation that will occur over time under the given service conditions, and thus whether we expect failure to occur or not. At the end of this module, you'll appreciate the importance of creep, how to design around it, and all the different processes that can occur depending on temperature, stress, and the type of material.